Hi dear students, so we have started our discussion of the exercise and its solutions, isn't it? So now we will discuss the question number 2.7. Okay. So till 2.6 we have already discussed in the last online class. So now let us come to the 2.7. A student measures the thickness of a human hair by looking at it through a microscope of its magnification 100. So the microscope is having the magnification 100. So he makes 20 observations and finds that the average width of the hair in the field of view of microscope it is 3.5 millimeter. So the length it is given in millimeter and it is 3.5. So what is the estimate on the thickness of hair? So we have to find out the real value of the thickness of the hair. So the data which are given is the magnification of the microscope and the observed width or the thickness of the hair. Okay. So that is given. So actually the equation for magnification is the viewed width divided by the real width, or the viewed thickness divided by the real thickness is actually the magnification. So the real width will be is equal to viewed width divided by magnification. Then you will get the real value of the thickness of the hair. Okay. So it is given that the real the magnified or the viewed width it is 3.5 meter. So 3.5 meter divided by the magnification value it is 100. So 100 will be the real width of the or real thickness of the hair, isn't it? So 3.5 meter divided by 100, that is 3.5 into 10 to the power minus 2 meter, that will be the real thickness of the human hair. So the equation that you have to remember is magnification, the value of magnification will be is equal to the viewed width, that is the magnified width, whichever the width you are observing through the microscope. Okay. So divided by its real width. So magnification is viewed width divided by real width. Now let us come to the 2.8. Answer the following. So you are given a thread and a meter scale. How will you estimate the diameter of the thread? You know that the least count of the centimeter scale is actually 0.1 centimeter, that is 1 millimeter, isn't it? So suppose if you want to measure the thickness of a wire or a suppose a thread, actually the equipment that you have to use or you are supposed to use a screw gauge, isn't it? The least count of the screw gauge is 0.01 millimeter. But in this case you are provided with a centimeter scale and thread, and it is asked to find the diameter or the radius of the thread. So you know that it is difficult, isn't it? Actually the diameter or the radius of the thread or wire is near about millimeter, 1 millimeter or less than 1 millimeter. So in such a case we cannot measure the diameter directly with the help of a centimeter scale. So there is an idea for that one. So that is actually you have to wrap the wire or thread over a pencil or a pen, okay, as like a coil, as like the spring. Okay, you have to wrap like that. So the wrap will be there. Actually the distance there shouldn't be any distance between the rings. Okay, should be close. And suppose a 10 number of wraps you have done, it means 10 rings are there. Now you can measure the length of that coil, isn't it? That coil like structure you can measure that length. Actually it may near about 5 centimeter or 1 centimeter, 2 centimeter, likewise it will be there. Then you have to count the number of rings, okay, count the number of rounds that you have done, and if you are dividing the length, obtained length divided by the number of rounds, okay, then you can obtain the length of one rotation or one round, isn't it, one circle. That is actually the diameter of the thread. In such a way you can find out the diameter of a thread with the help of a meter scale or a centimeter scale. So, you are wrapping it. So, how many turns are there? So, you are dividing the total length divided by dividing the total length by the number of turns, then you can obtain the length of one ring, that is actually the diameter of the thread or a wire. Okay. So, I think you understood that one. Now, the next question is that the B section, a screw gauge has a pitch of 1.0 millimeter and 200 divisions on the circular scale. Do you think it is possible to increase the accuracy of a screw gauge arbitrarily by increasing the number of divisions on the circular scale? Yes, absolutely, because suppose the division on the circular scale, if it is increasing, that means the least count is decreasing, isn't it? If the least count is decreasing, that means the accuracy of that measuring instrument is increasing. Okay. And actually there is one problem that suppose if you are increasing that number of divisions on that circular scale, then after a limit it will not be easy to calculate the values, because that the divisions are very close and we cannot differentiate the divisions. Okay. So, it will become difficult. That is why in the normal screw gauge maybe 50 divisions will be there or 100 divisions will be there. Okay. More than 100 divisions which will not be possible to calculate, there will be some confusions and it will not be differentiately, we cannot identify the divisions. Okay. I think you followed that one. Okay. Understood? Okay. Now, the next question is that the mean diameter of a thin brass rod is to be measured by vernier calipers. Why is a set of 100 measurements of the diameter expected to yield a more reliable estimate than a set of 5 measurements only? Actually, this question is related with the random errors, isn't it? So, the random errors happens. So, if you are taking the measurements more number of times, okay, and if you are taking the average, then when you are taking more measurements, that means the error may be on positive as well on negative also will be there. So, that will cancel each other when you are summing up, and when you are dividing it with the number of divisions, then the average value you can obtain and it will be more closer to the real value. So, that is why you are supposed to take, or we are supposed to take more number of measurements, okay, more number of measurements to avoid the error. Is it clear? Okay. So, that is regarding that one. So, now let us come to the question number 2.9. So, in the last question there is a C section. So, if you are taking 100 number of divisions, 100 number of observations compared with the 5 number of observations, the 100 number of observations will be more feasible and you can reduce the error more effectively if you are taking 100 number of division the measurements. Okay. Now, let us come to the next question, that is the 2.9 one. The photograph of a house occupies an area of 1.75 centimeter square on a 35 mm slide. The slide is projected on a screen and the area of house on screen is 1.55 meter square. So, what is the linear magnification of the projector screen arrangement? Actually, here the values are given in the area. The area, the first one it is 1.75 centimeter square and the other one the value of the area or the area which is obtained on the screen, it is 1.55 meter square. So, one is in centimeter square and another one is meter square. So, first of all you have to convert that centimeter square into the meter square. Okay. Now, the aerial magnification, it is related with that almost related to or similar to that 7th question. Okay. So, magnification, there was the linear magnification given, here it is the aerial magnification. So, aerial magnification is the area of the image divided by area of the object or area of the viewed image divided by area or the real area. Okay. So, here the image is having the area 1.55 meter square and the area of the object or on the film, actually that is the object. Okay. So that is 1.75 centimeter square. So when you are converting the centimeter square into meter square, you have to multiply that with 10 to the power minus 4. So 1.75 into 10 to the power minus 4 meter square. So then you can obtain the value as 0.8875 into 10 to the power 4, that is the magnification. Okay, it is 0.8875 into 10 to the power 4 times magnified the image. Now it is actually the aerial magnification. Suppose if you want to, actually in your question it is asked to find out the linear magnification of the projector screen arrangement. It is asked to find out the linear magnification. So if you are having the aerial magnification and you are supposed to find out the linear magnification, then you should take the root square or square root of the aerial magnification. Okay. So the square root of aerial magnification is actually the linear magnification, and where the aerial magnification is 0.8875 into 10 to the power 4. So the root of 0.8875 into 10 to the power 4 you have to do, then you will obtain the linear magnification, that is 0.941 into 10 square or into 10 to the power 2, that is 94.1. That is the linear magnification. Okay. So you whenever the question asks, you have to check whether it is asking for the aerial magnification or a linear magnification. Okay. In such a way you can find out the magnification. Is it clear? Okay, now let us come to the next question, that is the 2.10. We have already discussed that one in the classroom, but still state the number of significant figures with the following. Actually you can use the rules, okay, rules to find out the significant numbers, and you can find out that one as your own. Okay, as a homework you can do that one, 2.10. Okay, it is actually asking to find out the number of significant figures in that the values given. Okay. Now let us come to the next question, that is 2.11. The length, breadth and thickness of a rectangular sheet of metal are 4.23 meter, 1.005 meter and 2.01 centimeter. First of all, you have to convert the 2.01 centimeter into meter. Okay. That is 2.01 centimeter is actually is equal to 0.0201 meter, because whenever you are doing a calculation, the values should have a same unit, isn't it? Okay. Now let us come to the sheet. Actually the length, breadth and height, these values are given. Okay, it is a rectangular sheet when the height is included, it is not negligible. Okay. So let us come. We have to find out the area of the rectangular sheet. So actually on a rectangular sheet you can see there are 1, 2, okay, then 3, 4, 5, 6 faces are there, isn't it? So you have to find out the area of each face and you have to sum up it, then only you can obtain the total area of the rectangular sheet. Okay. So here this face, okay, this face and this face, okay, this one are having the same area, opposite faces. So opposite faces are having same area. Here the area will be B into H. Now if you are considering this face, okay, this one, that is L into B will be the area, and on the back side the same will be there, that is 2 times L into B, as well upper and lower portion. Okay, that is L into H will be this one and L into B will be the upper and lower portion. Front and back will be L into H, okay, upper and lower will be L into B. So the total area of the rectangular sheet will be 2 into L into B plus L into H plus B into H. So you have to substitute the values. L is 4.234 meter, B, that is breadth it is 1.005 meter and height H is 2.01 centimeter. So 0. That is centimeter is actually 2.01 centimeter is actually 0.0201 meter. So when you are substituting the values, you can obtain the value as 8.61564 meter square, but you have to follow the rule of significant figures. So in the multiplication, the result will be having the significant figure number of the individual value which is having the least number of significant figures. In this case,
the significant number value is 4, the minimum. Actually all the numbers, all the values are having the significant figure number as 4. So the answer should also have the significant figure number 4. So that is 8.616. We have to round off from 6 onwards. Okay. The non-significant number is 6 over here. So as the 6 is the negligible number, it is more than 5, the preceding element will increase by 1. So 8.615 will become 8.616 meter square. That is the area of the rectangular sheet. Now the volume is actually L into B into H. So you have to substitute the values and you will obtain the value as 0.0855289 etc. meter cube. And there also you have to follow the rule of significant figures in the case of multiplication. So the number of significant figures, the minimum number of significant figures in the individual value, it is 4. So the number of significant figures in the resultant value also should have 4 significant figure numbers. So it is 0.0855. The significant figure number will be 4 meter cube. Okay. So regarding these questions, now let us come to the next question, that is 2.12.
Okay, dear students, so come to the 12th question. The question is that the mass of the box measured by a grosser balance is 2.300 kilogram. The mass of the box is 2.300 kilogram. There is actually 2.3 kilograms. Okay. 2 gold pieces of masses 2.015 gram and 20.15 gram and 20.17 gram are added to the box. So first of all, you have to convert that grams into the kilogram, that is the SI unit. So what is the first question is that the total mass of the box, you have to find out the total mass of the box. So for the mass of the box is 2.300 kilogram or 2.3 kilograms, and mass of the first gold piece is actually 20.15 gram, that is 0.02015 kilogram. As well, the second gold piece is 20.17 gram, that is 0.2017 kilogram. The total mass of the box will be is equal to 2.3 plus 0.02015 plus 0.02017. So that is actually 2.34032 kilogram. Okay. But we have to consider the significant figure rule. So here the least number of significant figures is here, that is 2. Okay. So you have to round off the final value or resultant value to the least number of significant figures. So that is 2.3. From 4 onwards, it is in insignificant numbers. So you have to round off by 3. So here the 4 is negligible, that is less than 5, and there will be no changes, there will not be any changes in the preceding number. So it will remain as 3, that is 2.3 kilogram. Okay, that is the total mass of the box. Now the difference in mass of the gold piece is the second question. So the answer will be 2.02017 minus 0.02015. Okay. So 0.02017 minus 0.02015 is actually 0.00002 kilograms. In grams it will be 0.02 gram. Okay. So that will be the answer. Where if you are rounding off to the figure number, that is the significant figure number, so then there will be no difference. So that means it will become 0. So let us consider this value as it is. Okay. So now let us come to the next question, that is 2.13. The question is that the physical quantity P is related to 4 observable values as ABC and D as follows. P is equal to a raised to 3
b square divided by root c, that is 3 raised to 1 by 2 divided by d. So, you are supposed to find out the percentage error in the total calculation, that is p. And given that the percentage error in A, B, C and D are respectively 1%, 3%, 4% and 2%. So, what is the percentage error in quantity P? So, first of all you have to find out the relative error. So, it is delta P by P. If you are multiplying that with 100, then you will get the percentage error, isn't it? So, delta P by P is actually is equal to delta A by A, that is all raised to 3 is there. So, 3 into delta A by A plus 2 into delta B by B plus half of, that is c raised to 1 by 2. So, half of delta C by C plus delta D by D, that is all raised to 1 only there. So, delta D by D. So, all into 100 will be the percentage error. So, delta A by A into 100 is actually 1%, it is already given. The percentage error in A is 1%, in B it is 3%, C is 4% and D it is 2%. So, the total percentage error will be 13%. Okay, delta P by P into 100 will be is equal to 13% as per the rule of finding the error in the products, isn't it? So, the relative error in the product will be the total sum of the relative error of the individual values, and into multiply, if you are multiplying the relative error with 100, then you can obtain the percentage error. So, 13% is the actual value of the percentage error. The next question is that what if the value of P calculated using the above relation turn out to be 3.763, to what value should you round off the result? That is the question. Actually, the obtained value it is 3.763, but you know that the percentage error was actually 13%. So, you have to round off the significant figure number in the percentage error it is 2. So, you have to round off the value to 2 significant figure numbers. So, 3.76, from 6 onwards it is insignificant number. So, when you are rounding off that to the figure number, significant figure number 2, then the 6 actually the 6 value it is greater than 5. So, the preceding number will be increased by 1 and it will become 3.8. Okay. Okay, now let us come to the next question, that is a book 2.14. A book with many printing errors contain 4 different formulas for the displacement of y, a particle undergoing certain periodic motion, where the A value is actually, the A is the maximum displacement of the particle, that is amplitude, V is the speed, T is the time period. Okay. So, these are the values given. So, the first one is that A sin 2 pi t by t, where you have to use the dimensional analysis of the trueness of an equation. Like you can follow that method. So, here y is equal to A sin 2 pi t by t, where first of all you just consider the sign. You know that if a sin x, if it is given, then the dimension of the sin value will be 0. Actually, there will be no dimensions for the trigonometric the values, as well the trigonometric significance, that is the for which value you are doing the trigonometric operation, that value should also not having any dimension. Suppose if I are considering the sin x, then the dimension of x will not be, actually it will be m raised to 0, l raised to 0 and t raised to 0. There will be no dimensions for the that value, particular value, the significant. Okay. Now, let us come to the first question, that is y is equal to A sin 2 pi t by t. First of all, consider whether is there any dimensions for the 2 pi t by t. No, actually 2 pi there will be no dimensions. T, the time, t raised to 1, but divided by the time period, that is also time, t raised to 1 divided by t raised to 1 will be cancel each other. So, there will be no, there is no dimensions for the trigonometric significant value. And now, let us come to the A. The significance, the dimension of the A is actually L, as well on the left hand side it is L, and y is equal to, if you are considering the total equation on left hand side and right hand side, the dimension formula is same only. So, the first equation is true. Okay. Now, the second one is y is equal to A sin Vt. Actually, I have already told you that if you are considering a trigonometric value and the value for which you are applying the trigonometric operation should not have any dimensions. But here the velocity into time is actually having the dimension as L. Okay. So, if by considering this itself, okay, this one itself, if you are considering, the equation is false, because the dimension of the value for which you are applying some trigonometric operations should not have any dimensions. Okay. Now, let us come to the next one. That is y is equal to a by t sin t by a. Okay, t by a. Here also the time divided by acceleration, that is time divided by amplitude. Okay, a is amplitude, that is t, the dimension will be there will be dimension for that value also, isn't it, for the sine value. So, then also the same thing as in the earlier case, this equation is also not valid. As well, a by t, that is the time displacement divided by time, for the dimension of that one, if you are comparing the dimension on both sides, which will not be equal. So, this equation is also not valid. Now, the next one, a by root 2, a by root 2 is okay, that is a L only, root 2 is not having any dimensions. So, the dimension on a, it will be L, for y the dimension it is L only. Sin 2 pi t by t, the dimension will cancel, as well here also the dimensions will be cancel each other. So, there will be no dimensions on both left and right hand side, the dimension value it is L only, L raised to 1 only. That means this is also a valid equation. So, as per the dimensional analysis, the equations 1 and 4, that is the y is equal to a sin 2 pi t by t and y is equal to a by root 2 of sin 2 pi t by t plus cos 2 pi t by t will be, or these are the two equations which are valid by the dimensional analysis. Okay, is it clear?